Okay, so it's been almost a month now. We got a gap of almost 1 month as as I told you, I was busy with my shifting of house. So after that, I didn't get internet for 2 to 3 weeks. That is also one more problem. But from now, we will go through regularly. We will not miss any classes. So in the past, I took 3 classes on partitioning. So I already requested you to watch um, those 3 sessions just to catch up with this session. Of course, if you join just for this session, it's okay, fine. I will make you feel comfortable. But this session is more about internals, and you will avoid some surprises if you got to know about this. This will be very interesting. These are internals, but many of us will struggle to understand this. So trust me, this class will be very interesting, and it helps you to understand the partitioning and indexing architecture at the same time, both together. Very simple examples, and I will make you feel comfortable once the session finishes. Okay. So first I will just create the non-partition table, and I will show you how it looks. And then we will go through a partition table, and I will compare both of them, and I will make you feel comfortable with both the architectures, indexing and as well as partitioning, both together. If you have any questions, you can stop me anytime. Okay, so let's start the session. I'm just creating a non-partition table. Nothing great here. I have 3 columns or 4 columns: ID, column A, column B, and created date. So I have 4 columns, and I'm inserting some data into that 4 columns, what I got. And I'm going to create cluster index on ID column, just on ID column. Okay, so let's understand this first, and then I'll show you how it looks when it comes to partition table. The same table, but it will be partition. That's the only difference. So let's start this. I will take any of the databases. For instance, I will take this partition. Okay, I'll take DemoDB. So as I told you, I'm just creating a table and then loading some 1,000 rows and creating a cluster index on this first column, ID, and then we will see how it looks. So let me run this one shot, or else first I will do this. Table has been created and I'm loading 1,000 rows. And then I'm creating clustered index on ID. Okay, so let me show you how the content looks. Select start from non-partition table. So I got 1,000 rows like this, 1 to 1,000. And it's all filled with A, it's all filled with B, and here we got some random dates, some dates. Okay, so this is how it looks. And now I'm just making use of dpcc-ind to show you how it looks, how the pages and how the information is getting stored inside the cluster index. So for that, I can make use of new DMVs from 2019, I believe. We have something called as DB page info, and there is one more DMF by name DMDB database page allocations. You can make use of them to understand. These are the new ones that you can make use of. But for the moment, I'm going to make use of DBCC-IND. But since we are always trying to explore the new things, I'm just letting you know these are the new DMVs that are there from 2019 to get the same information. But I'm rather comfortable with IND, so that is the reason I'm using DBCC-IND. So let's see what is there inside my cluster index. I don't have any other indexes. I just have only cluster index, nothing else. So DBCC-IND needs 3 parameters. One is database name, which in our case is going to be DemoDB, and the table name, and the mode. There are three modes, 3 or 4 modes in IND. So I'm using dbcc demo db, not sorry, table name, database name, and mode. So when I run this, I got this information. So for 1,000 rows, I'm having 1, 2, 3, 8 pages. One is IAM page or GAM, I mean the first page, the PFS page or IAM page, and the other pages are data pages. So how to identify whether it is data page or index page is with the page type. Okay, page type 1 is nothing but page type 1 is data page. So these are the data pages. Any questions here up to here? Okay, so let's understand one of the pages and see how it looks. So it will be demo DB, and I'm picking one of the pages. You can pick any of the data pages, like any of these three, any of these 6, any page. So I'm picking this page randomly. So let us understand what is there inside that page. Okay, I got this information about the pages, what it contains internally. So first thing first, what you have to understand. Okay, how many columns do I have in the table? ID, column A, column B, created date, means 4 columns. So I have ID with 369, column A, all A's, column B, all B's, and some date. So we got the 4 columns. From where I got this value, unifier? Why I'm getting this unifier? I didn't add any column by name unifier, but SQL Server is showing me column 0 as unifier with a value of 0. Why did I get that unifier? Anyone knows? Participants, anyone knows why did I get unifier? Did I add that? I didn't do that, right? Yes, no, don't know. Say something. At least I can get some pulse.
No idea.
No, Gaurav.
Okay. So let's keep this. And so now you have seen it, right? I mean, you can see something by name unifier. Something came in between and we didn't add that column. So let me drop the table and do it again. Drop table non-partition table. Before I drop, I will do one thing. I will also create one more non-clustered index, and then I will show you how it looks. So let me create a non-clustered index. I would like to create non-clustered index on column A. Okay, so I'll show you how it looks and you can understand very easily. Create index name on table name on column A. So I'm creating this. It's done. So now I would like to see what are the contents inside that non-clustered index. So let's move on. And here I have to change this to demo DB. So 1 is cluster index, as you all cluster index index ID is 1. I think I said some modes. It's not for modes. It's about cluster index and non-cluster indexes. So I think IND takes 1 means index ID, which is the cluster index. 2 means non-cluster index. Anything after 1 is non-cluster index. So here I'm passing one of the non-cluster indexes, what I just created. Okay. So any questions? So this is how it looks. So now for the cluster index, if you see, when I run this cluster index, I got page type as 1. So page type 1 is nothing but data pages. So these are all the data pages what I got. Inside this data page, we have the data, as you can see here. So this is the data what I can clearly see. So I have a record ID with 369 and some date. Okay. So but when I do the same thing for non-cluster indexes, this is how it looks. And the page type is 2. page type is 2. It's not page type 1. It is page type 2. So now I have to take one of the pages and then I have to see what are the contents inside that non-cluster index. Okay, so I'm going to take one of the pages. I can take this or this, any page. It's our choice. So let me take this DBCC page and I will take this page 77088. So I got the data. See, I got some rows here, 338, 359. So this is nothing but ID, our ID column, what I just created on the top, and this is our cluster index. So we have ID and non-cluster index. What does it contain? Non-cluster index contains only the information with respect to that column. So here I created non-cluster index only on column A. So that is the reason I can see information about column A. Why I got cluster index alongside with non-cluster index information means column A, because non-cluster index will make use of cluster index to fetch the pages from the base table. Okay. Without that, you cannot get the pages. So if it is cluster index, this is how it looks. And if it is non-cluster index, we will get something called as RIDs. Okay. So if you see again here, I have the column A, which is non-cluster index. I have the information of cluster index, my rows, the real rows, 351, 352, all those things. And there is something called as key hash values. It's a bit difficult to explain you now. I will take some other time. DBCC page can also tell the page that has been linked to DCM page. DCM page number we need to check. We will check that. So this is how the information is being laid out. So I have column A, I have cluster index, the ID values and some key hash values. Again, you are seeing this unifier. Unifier as 0. Everything is unifier as 0. I didn't add that unifier. So you can clearly see that unifier is there in the cluster index, means nothing but our table. Okay, and even in the non-cluster index. So this is what I'm talking about. Non-cluster index and cluster index, both of them are having unifier information. So I'm going to create the same table. I'll drop this, or I'll do one more thing. So let me do like this. Copy, we'll take new window. I'll say non-partition table 2. Same thing, no changes. Now I'm just creating the table again. I'll run up to this. Non-partition 2, and we're going to create 1000 rows. And now this time I'm saying create unique cluster index. Okay, I'm not saying create cluster index. This time I'm saying create unique cluster index. Last time I said create cluster index, but this time I'm saying create unique cluster index. Only keyword that is missing from the last time is unique. Okay, nothing, no changes. So I'm going to create unique cluster index and I'm going to observe the pages just like what I did. And I'm going to grab one of the pages. Let's say the first page. If you want, the data also remains the same. There is no change. 1, 2, 3, 4, up to 1000 A's, B's, and some dates. And now if I go and just put this number, whatever the page that is popping up, and this is how the information looks. And now let's go to the records. Now I'm not seeing that unifier. I'm seeing only ID, column A, column B, created date. Exactly like what I'm having. Okay. I am not seeing unifier. Why I'm not seeing unifier this time? Why was I able to see the unifier last time? The previous one and this one. So that is where the concept lies, guys. SQL Server will internally add a unifier if you are creating a non-unique, if you're trying to create cluster index and non-unique columns, means, for example, I'm saying ID here, I am just saying 1 to 1000. So every record is unique. So that is the reason I'm able to create unique cluster index. It is helping me to create unique. What is unique? What is primary key? First of all, let's talk about from primary key and we'll get to unique and this stuff. So primary key is nothing but unique and not null, right? Unique and not null. That is the reason whenever you create primary key inside SQL Server, by default, it creates cluster index. Of course, you can create primary key even on non-cluster indexes also, but I'm talking about defaults. If you just create primary key on any of the columns, it creates unique cluster index, and that is also not null. We'll just leave about not null for a second. We'll just focus on unique. So whenever you are creating a primary key on any of the columns in SQL Server, you are getting unique clustered index by default. If at all, if you're creating any index like this, means you are not specifying unique. And if you're just saying create cluster indexes, SQL Server will add a column by name Unifier just to make things easy for itself. Okay. So this is very important thing that you have to understand. Did you get the concept? Why I am getting Unifier? When will I get Unifier? Two things you have to understand. When will I get Unifier? I will get Unifier by default if I'm creating a cluster index. If I'm not specifying unique keyword, or if I'm just saying create cluster index, something like this. So you don't get Unifier if you are doing it via primary key or when you are saying something like create unique cluster index. For example, let's imagine this is a table. Okay, this is a table, and I'm trying to create primary key on I created date. Okay, I wanted to create primary key on created date, and I created primary key using non-cluster index. Means I will say, how many of you know that we can create primary key on non-cluster indexes? Is it
Yeah, I'm
possible?
just verifying. I think so, yeah.
Let's do one thing. I can show you. That's not a big deal. But just to let you know, guys, don't think that primary key can be created only on clustered indexes. I mean, you can make primary key non-cluster index also. So let me show you a simple example rather than talking this stuff. Um, let me create this, or else I think I can get it from here also. Mm, okay, let's create primary key non-clustered index in SQL Server. So we always think that, okay, primary key can be only created on cluster indexes. That is not the case. So let's take an example. So this is primary key with will default to cluster index, which we all are aware of. So by default, it creates the primary key, and this is how it looks. So if I am saying, for example, like this, ID not null, primary key non-clustered. So if I'm saying primary key should be non-clustered index rather than clustered, if it just leave this term or class, it will be cluster index by default. But if I don't want that index to be clustered, I can say primary key non-clustered. So when I say primary key non-clustered, my index definition will be only with non-clustered indexes. It's not clustered. So let me show you. So let's just take this. Um, Yeah, primary key is the constraint. Constraint is different, index is different. So let's move on to the next page and let me just show you how it looks. Okay, so now let's try to add some records. I will say, what is that we have? Column one int. Okay, let's just quickly add some records. Insert s table values one comma column one is also int. I will say 100. Okay, so just to see how it looks. And say 2 and 200. Just two values are good enough to understand the concepts. Okay, so now if you see, I will have two records. select star from test table. So 100 into 200. So let's do the same thing. So let's understand DBCC IND. So this time it is test table. Okay, so this is how it looks. Test table. I'm passing why I'm able to get this number 1. I mean to say about this field. So this is clustered. Sorry, this is non-clustered primary key. What I got. So let me show you how it looks. So this is the data page, right? Let us take this and let's grab the contents, how it looks. Demo DB test table. Let me run this. Page PID. I don't need to go up to this level. Just wanted to show you how it looks. Okay, so we can create primary key non-clustered also. So you can clearly see ID is 1 and column 1 is 100. And I have one more record, ID 2 and column 2, 200. So this is how it looks. So primary key can be non-clustered also. There's no reason to say, okay, primary key should be always clustered. That is first thing. Second thing, what you have to understand is this unifier concept. If here you can see, and even this test table, I am not getting that unifier. When I say primary key, you will never get unifier. You get unifier only if you are saying create cluster index. Only if you're saying create cluster index. In this case, you will get unifier. That is what I'm trying to establish here. If you have any questions, I will stop here because you have to understand the concepts before I move on. If you don't get this concept, you will not be able to digest the partitioning concepts. So these are interlinked. If you want, I will repeat this.
So MC, you mean to say when we are creating a cluster index,
Yeah.
so unique identifier column will be there instead of selecting any column like you have selected a partition table. I mean, generally we select for indexing, we select for like the column which we having, integer value or unique value, right? So is
Unifier
it not like that? Yeah,
gets added internally by SQL
yeah,
Server
yes,
to identify
yes, yes.
the uniqueness, to create that uniqueness. For example,
But we have another column. If we are creating a cluster index, we have another column to identify each row uniquely, right? Apart from
yes, yeah, if you creating a
this
cluster
unique
index,
identifier.
yeah, create cluster index. If you see here, I'm saying create cluster index. Okay, create cluster index. I'm
Correct,
not
correct.
saying unique. So if the records are not unique, in this case, this is unique. Okay, in this case, the records are unique. But just
Mhm.
imagine if the records are not unique. Let's do simple example. Okay, I will drop this and I will say,
That's why, because you have selected the column that records are not unique. But generally, when we create an index, we suggest to have index on the particular column that is already unique, right?
yeah,
So,
generally, but
yeah.
there are cases where people will enforce primary key on non-clustered as non-clustered. Okay, and they will create cluster index on some other column. So that there are chances.
Mhm.
Depends
Correct.
upon the business needs. Let me do the
True, true.
simple
That's why I
example.
was trying to understand. Yeah.
I will just say int not null. That's it. Okay. So this is how it looks. And now I'm saying uh, create cluster index. I'm not specifying anything as unique here. I'm just saying cluster index. Create cluster index name, on table name. And now I will try to insert the records and make them as duplicate. Let me show you. I will say ID, right? ID is the cluster index. Okay. So 100, and then I will say 200. Means I'm trying to insert duplicate records intentionally. So you can obviously insert duplicate records because you are not forcing any uniqueness here. If primary key is there, definitely this would have thrown error saying that we already have a value with 1. You cannot add one more value. And even if you have create unique cluster index, it would have thrown error. since it's just cluster index and I'm not forcing any uniqueness, definitely it will allow me to enter duplicate values. Okay. Now
Yeah, but if we mention unique, then it will
it
allow
won't
only one.
it won't allow. I mean
Yeah,
to say
yeah. It will not allow. Yeah,
it will
yeah.
not allow.
Null value is different. Yeah,
Null is
correct.
different. Null is different. We are talking about
Yes.
only
Yeah, we
uniqueness
can
here.
leave it. Yes, correct.
So for if you see now, if I just go there and grab this page number, and now you will see definitely a concept by name unifier getting into picture. Previously, we didn't see that unifier, as you can say. Now, if you see unifier 0 for row number 1, and now unifier 1. See this unifier 1. Why I got unifiers all as 0 here? Because my ID is not having any duplicate values. That is the reason you are seeing unifier as 0. But here you can clearly see, since I inserted duplicate records intentionally 1 and 1. Now, if I am observing the pages, unifier is there automatically because my index is not unique. That is first thing. Unifier got added, and it is starting with 0. Unifier will start with 0. So it is 0 just to identify that record. And now, since I got duplicate record with ID as 1, now my unifier got changed. Unifier is showing as 1. This way, SQL Server will able to identify the particular record. If I say select star from test table where ID equal to 1, how can it will figure out what is that relevant other columns information? It has to have some kind of identity, right? Some kind of uniqueness. So that is the reason SQL Server internally is forcing itself to be unique by adding this column unifier. This happens only if you are creating cluster index as non-unique. Very simple. If your cluster index is non-unique, SQL Server will just add that unifier stuff internally so that it can identify the values uniquely. This is the concept, guys.
So yeah, so if we add here create primary key, I mean, if we have a primary key on this cluster index which we are creating, then it will not
It will
add
not
the
allow
unique
you to.
identifier.
It will not allow you to enter
Yeah,
the value. First of all,
duplicate values. Yes,
duplicate values will not get added. So there is no need for me to add unifier again because the values itself are
correct,
unique.
correct. Yeah, and the same for unique cluster index also,
Same
right?
thing. So
Because it
you
will
want.
also the not
Okay,
allow. Yeah.
let's do very simple. So since people are just wanted to have something very simple, no need to do some great demos. So I'm dropping this same thing. Okay, I'm saying create unique now. So if I say unique, there itself, it will prevent you to add duplicate values. Okay, so one is 100 first row. Okay, fine. If I'm doing this 200 like just like what I did, it won't tell you. It will
Throw error.
throw an error straight away. So then there is why
Duplicate.
should I add unifier now? No need.
Correct, correct. Because it's already
It's already unique.
not aligned.
Yeah, it will not allow. Did you get the concept, guys? Very simple, but you have to understand basics. Any question now?
So now it's clear, Vamsi. Thanks.
It's clear now, right? Can I
Yep,
move
yep.
on?
Thanks, Ishwarla.
Yeah. I'm hoping it is clear and I'm moving on. Okay, so now you know what is this concept of unifier and why I got zeros here also, because since that column ID itself is unique in my case, for in that example, you are seeing zeros. Everything is being projected as 0. Okay, that is the only thing. Okay, so let's move on now.
Vamsi,
Yeah,
just to confirm, 0 means unifier is enabled and 1 means it is not.
no,
Correct?
no, 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 nothing like that. Nothing like that. Who asked this question? 0 and 1. I mean,
Yeah, Nikhil here, Vamsi.
Nick here. Okay, Nick. Just to show you up, if you take this example, of course I deleted this. Okay, let me run again. 1 second. One, 200, 300. Okay, and I will delete this keyword. Okay, I'm creating the table and I'm creating cluster index, which is not unique, and I'm inserting duplicate values as you can clearly see 111. Okay, and now I'm running the same thing, getting the page number, and if you see the records now, you will see unifier and observe the unifier values carefully. Okay, so first one unifier is 0 for ID1 and column 1 as 100.
Yeah.
You can see this. Okay. Second value, Unifier 1, ID1, column 1, 200. Okay.
Yeah.
Go to the third last row, Unifier 2, ID1 and column 300. So let me grab these contents to make you clear. And then why I'm saying all this stuff, you will understand why I'm doing this. You will get to know shortly. Unifier. And then this one. So what are my rows? As you can clearly see, what are my rows here? 1, 100, 2, sorry, 1, 100, 1, 200, and 1, 300. So Unifier 0 for ID1 and column 1 as 100. And Unifier 1 for ID1 and column 1 as 200. And lastly, third row is 300. So if I go there, it is Unifier 2, ID1, column 1, 300. If I add one more value, what will happen? It will be Unifier 3.
4.
I mean, it starts with 0. So it will be Unifier 3. Okay.
Correct, yeah.
If I add one more thing, it will be Unifier 4, 5, 6, 7. How many duplicate values you enter, those many unifiers will get added. It gets incremented. The value gets incremented.
Yeah.
It's not 0 means enabled, 1 means disabled. In this case, I don't have any duplicates. That is the reason Unifier is being projected as 0. If I have duplicates like this, that number will get incremented. Like as you can clearly see, for 300, I got Unifier as 2. Just to add one more, if you want, I don't need, but just to double confirm. Of course, it's not at all needed. Sometimes it happens. 1 second. I pressed the wrong key. What is that? Insert. Okay. Delete 400. Okay, one more value I'm adding. And then if you see here at the very bottom, you will see Unifier as 3. See, Unifier as 3 for the column 1, 400. That's it. Very simple. So now, is this clear? I hope so.
Yeah. Thank you.
Yeah. So one more question. Unique and primary key to enforce unique and don't have unique identifier from single. But if you don't have unique constraint, then we'll have identifier column. That's what we discussed, right? So we are not talking about what is that enforcement of uniqueness. We are just dealing with when Unifier comes into picture and when not. Simple. We will talk about constraints later because my class is not about constraints now at the moment. So I'm moving on. Okay.
Vamsi, small
Yeah.
clarification.
Yeah.
So now the ID value is 111 and the another value is 100, 200, 300. Like
Yeah.
in that
Yeah.
scenario, the unique identifier started with 0 and the ending
Yeah.
the sequences is like that.
Yeah.
At
0,
the same
1, 2,
time,
3. Yeah.
0, 1, 2, 3. Now the duplicate key, the key value of ID, it becomes 2 and 100, 200, something like that. Then the
What
unique
happens?
identifier
Okay.
also starts with 0, 1, 2, 3. At the same time, the ID value of primary key values becomes as 2, right?
Just for your example, since you brought this doubt, okay, I'm just adding one more thing, but this time 2 as I'll say 1000 just to differentiate. Okay. And I will add one more value just to show you up. 2 and then I will say 2000. Finally, one more value and I'll stop here.
Yeah.
2, not 2. I will say, okay, 2 and then I will say 3000 just to show you how it looks.
Yeah, here again the unique identifier come as a 2, 1, 2, something. 1, 0, 2, something like that.
So let's 300 is done, 400 it's done. Okay, now we are going to that unifier starting with again 0. Okay, unifier started with 0 for ID2 and column 1 as 1000. And unifier got incremented with 1, ID2, column 1, 2000. And now you will see unifier as 2 for value 2. Okay, so for each value, the unifier gets reset automatically.
Yeah.
Okay.
So
So
it starts with the again
0.
0 to
Yes.
sequence.
Yes. Yeah. So
Yeah,
for
that's what I
this,
want to make
yeah,
sure.
yeah,
Yes,
sure,
yes.
sure.
Thank you.
So just imagine we have a column here, Unifier. So it will be 0, 1, 2, 3. Again 0, 1, 2. So that's how it gets reset automatically. It gets reset, and that gets uniqueness automatically. SQL will forces that uniqueness to understand internally about it. I mean, SQL has to do this because otherwise it cannot identify the pages. So that is the reason people suggest you not to create non-unique cluster indexes, because you are adding Unifier onto the top of the tree. Imagine it's a very big table, some 10 terabytes table, and it has some thousands of pages. Now, if you create index something like this, create cluster index without forcing uniqueness, what happens? This Unifier gets value. This is an extra column that is getting added internally by SQL Server. So you will get an extra 4 bytes. You are wasting 4 bytes. Of course, 4 bytes is nothing for you, but it comes into picture when we are dealing with bigger tables. So that is the reason SQL Server, I mean, not SQL Server, people say not to create non-unique cluster index. Simple, as simple as that. But there are reasons, business requirements, where I have to create primary key on non-clustered. I should create primary key as non-clustered, and have to create cluster index on some other column. And that some other column, if it is having unique values, I can create unique cluster index. Imagine I don't have any uniqueness. If that is the case, I have to create cluster index. But that is the worst way to design any table. When you are dealing with cluster indexes, it has to be unique. Okay, but I don't know. There are some cases where you have to create non-unique cluster index. It depends upon business requirements, purely business requirements. This constraints primary key, foreign key. It's how your tables are aligned, and your needs, your business needs comes into picture. It's not about DBS, but DBS has to understand all these things when you are dealing with this kind of concepts. Okay, I hope it is clear now.
Okay, in that
Yes.
case,
No,
if
one more.
they,
Can we?
as per this,
Okay, I will take one by one. Yeah, go ahead.
yeah, in that case,
Hmm.
if the business want to have non-cluster index with the like, what would the performance kind of issue? Is there any performance kind of issue specifically?
We'll talk about performance later. I will take your question. There are examples for that.
Okay.
Performance is something different. So you have to understand what happens if I do that, and how about the blockings. Especially blockings are the ones that comes into picture if you don't follow certain rules. So I have one more demo for that. I will create that and I will show you.
Okay, thank you.
Yeah. Any other question?
Yeah. Can
Yeah,
we
Vamsi,
differentiate with identifier?
Can we differentiate with identifier? Means
Like say, suppose it will create automatic like 0, 1, 2, like
you
unique
cannot
identifier.
you cannot add, I mean, you cannot say unifier column. You cannot say, because if you see here, when I'm saying select star from table name, am I seeing unifier here? You cannot.
Mhm.
SQL Server will do that internally for you. You cannot do it. It's not possible because it's not getting added to the physical table, means the physical records.
so
Okay.
my
Okay.
question here,
Yeah.
my question is there, we have a different, I mean, two same unique identifier values, like we were resetting the values, right? I mean, SQL
Yes.
Server internally
Yeah.
resetting starting from 0. So how it will fetch the data? Because we have another value for the same, I mean, on the 0, we have another value, and again, it will reset
You.
and we have
I
another
got your
value,
question.
like
I got your question. So it's very simple.
two, yeah,
It's very simple. Unifier. Okay. You are creating cluster index on which column? ID, right? So ID is the one that is helping you to navigate the pages. First thing first. So
correct.
ID is the one that is helping you to retrieve the pages. So when you
Mhm.
are asking about ID, you will definitely say ID1, ID2. So it knows where ID1 is, where ID2 is. Is that clear? First thing first. So when
Correct,
you are saying the
correct, correct.
pages, I know ID1 means I have these pages. ID2 means I have these pages. Imagine page number 100 is for ID1, page number 200 is for ID.
But
So
sorry to interrupt you,
let me
but
finish. Let me finish. I will,
yeah, yeah,
because
but here if you can see,
no, no, no.
sure, sure.
I'm getting your question. There's nothing that I didn't understand your question. So first you have to understand ID1. Okay, I have to draw this to make you understand then. So I think, what is that? Draw.io, something should be there, right? Mm. Draw. I'm not good at drawing. Please bear with me. Oh, this was our last partition class. We didn't start the partitioning yet. We are still discussing about this stuff. This is what happens if I do into, if I go through these internals, this is very difficult. Okay, so this is, imagine this is a B tree. Okay, and I have some values. Just imagine like this. Let me draw one more line. Okay, just imagine. Okay, this is value ID value as 1, and this is ID value 2. So I have a different page here. Just imagine this is a page and this is a page. So ID1, ID2. Unifier is getting reset. I do understand. Unifier is getting reset, but it is getting reset for different value, not for the same value. First thing you have to understand, it's getting reset for different value. In our case, ID1 and ID2. Okay, let me do this as well. And text, let me say ID equal to 1, and then ID equal to 2. So imagine ID equal to 1 and ID equal to 2. So internally, if you are pulling the records for ID1, it has to search for the records only for that page. First, you have to understand page. It's the page that matters most, not the records. First of all, it has to identify the pages uniquely. So you have pages for that. Okay, for example, some page number, imagine it is some 768 page. Okay, imagine you are pulling page number 768 where you have ID1 and ID2 both together. Okay, both together. So it comes here. Imagine this is a B tree. 768 is your leaf level, intermediate page, and it goes to the leaf page, and it has the value as 100, 1, 200, 1, 300, 1, 400, and then again 2, 100, 2, 200, 2, 300, something like this. So when you are retrieving the pages, Unifier is coming here, and if you are retrieving any particular record, here I am forcing uniqueness. Let me go there. How can I mean, it's difficult to picturize this. I'm not good at drawing. That is the problem. So I will
No
take
issue,
your
no issue.
question.
I was just thinking there will be again duplicacy.
No, there is no
Like we are
duplicates.
saying ID1 is 4 times, right? And different record, and ID2 is 3
Three
times
times.
and
So
different record. So how it will fetch for particular 100 for,
because
because the
uniqueness
ID is
is
showing
here,
1.
right? Uniqueness is here. So ID1. So imagine you, let's do one thing. Okay. I will add one
So
more column.
sorry to take more time on this.
Yeah,
But
it's
I
very
was
simple. You
little
don't need to
confused.
go up,
Yeah.
you don't need to make yourself into that area where you can, make yourself uncomfortable. It's very simple. Just imagine here. Just imagine 0,
Mhm.
1, 2, 3. Is it not unique now? 0, 1, 2, 3. Are my records unique? Just
Correct.
imagine there is one more
Yeah,
column.
it is unique.
Unique. And let me
Yeah.
add one more scenario. 0, 1, 2. Are my records unique? Just say
Yes.
two. If I combine ID and Unifier both together. Okay, I'm talking about ID and Unifier. ID 1, 0, 1, 1, 1, 2, 1, 3. Definitely unique.
Mhm.
Again, 2, 0, 2, 1, 2, 2. Unique or not?
Yes, unique.
That's it.
So it will be it will be the combination ID and
Combination.
unique
It's a
identifier.
combination. It's your cluster
Correct,
index
correct.
and Unifier. It's making it as unique. If you just rely
Yeah,
on
I
cluster
was
index,
thinking, I was just relying on
no,
one thing. That's why
no,
I
no,
was
that's not the
confused.
case. No, that's not the case. Okay. Finally, I'm happy that everyone understood this concept. Of course, this is not an easy concept to digest because of the complexities. I hope now it is clear. Okay, shall we move
Yes,
on?
ma'am. Thanks.
Yeah,
Yes,
yeah.
ma'am.
Yeah, sure.
Okay, same example, no change, nothing. This time I'm just creating partitioning. Okay, the same example, but with partitioning. That's the only difference. Let me create this, some partitioning function and partitioning scheme. And then the same thing I'm going to create this on for partition table. Let's add partitions function and scheme. Again, guys, if you have just joined for this class, my previous classes, we discussed about function and scheme. So I cannot repeat this again. So I'm sorry for that. You can watch the previous sessions. Okay, I'm just going to create partition function and partition scheme. So I have any values less than 2017 falls into first partition and second and third. So let me do this. Don't need to think about like how the partitioning is aligning, and not that. My focus is to make you feel comfortable about indexing and partitioning. So as I told you at the beginning, you will understand why I'm talking about this just in few moments. So same example, this time I'm saying like this. Understand the basics first. That is what matters most. Same thing. If you see the difference here, I'm not saying, see here, this is non-partition table, so it definitely sits on the primary file group. But here it sits on the partition scheme by name PS partition table. Okay, so it sits on the partition scheme. So now I am creating partitioning on created date. Understand the concepts, guys. It's very important that you have to understand the concepts. It's all about concepts. You are creating partitioning on which column? Created date. Okay, you are creating partitioning on created date. You are dividing your data or rows based on this created date. Let's first do that. Okay, and now you are inserting the same records. It's just, I just partition my records based on created date. I didn't create any index. Okay, that is what you should understand here. Did I create any index? No, I didn't create any index now. Okay, let's first understand the concepts, then you will get to know. 1000 rows, same example, no change. So I got my 1000 rows. Let me show you how it looks. Select start from partition table. I got my 1000 rows. 3, 5, 10. Why I am getting 3, 5, 10? Why not ID 1, 2, 3, something like that? Do I have that value of 1 here? ID? Yes or no? Obviously, it should be there where ID equal to 1. Okay, it is there. So don't worry. But my records are partitioned based on created date. Again, I'm saying my records are partitioned based on created date column, but I don't have any indexes till now. It's just a heap table. Is this a heap table or non-heap table or cluster table?
Heap table, because we don't have any
Yeah, any indexes.
cluster index.
Yeah, we don't
I
have
mean,
any.
when
Yes,
we
yes.
have a cluster,
Yeah, yeah,
then it will not be.
yeah. So we don't have any cluster indexes. So obviously this is a heap table. So we do have data with ID1, but it is appearing at the bottom because we are when SQL Server is in retrieving the data, when I don't say any order by column, it is giving me in random fashion. Okay, so if you want, I can just show you like this, order by ID. Okay, so now I got same records, no change, no change. Okay, now let's come back and let's understand the concepts. So this time I'm again creating cluster index, again creating cluster index. Is this cluster index unique or non-unique? Obviously it is non-unique. If you see, I am not saying unique value here. I'm just saying non-unique. So let me add this cluster index. It got created. Okay, so now let's understand the concepts again. Same example. Demo DB, right? Okay, so like previously, we got the rows now, and we got rows for our cluster index, partition 1. So I can take any of the pages. If you see now, previously, let's understand the concept side by side. What is the partition number here? It's always 1. Even though if you're not partition your table, guys, internally, there will be one partition per table. Okay. It's all about concepts again. For each table, no matter whether you have partition or non-partition, that doesn't matter. SQL Server will have its partition number as 1. If you are not partition your table, if you have partitions in your table, like what you are seeing, there will be one more thing, and this gets incremented partition number, and the rows are divided based on the column on which you have created. So we'll talk about that. You'll get to know. Don't worry. I'm just letting you know. Now you are seeing this partition number. Previously, that was not the case. You add any n number of rows, doesn't matter. Here I added 1,000 rows. Even if I add 10 lakh or 1 million, 10 million, the partition number will be 1. But here that is not the case. So we have partitions here. That is first thing what you have to understand. So coming back to this example, so let's take a page and let's see how it looks. Okay, so this is how it looks. That's fine. So now again, I'll get Unifier, no doubt, because I'm not forcing any uniqueness for my cluster index. So it will add Unifier. And my ID is 445. That's fine. And I get created date, column A and column B, and some slot key hash value. Okay. So observe the output carefully, guys. There is a trick here that you have to observe very carefully. Okay, just watch out very carefully about the output and the table structure as well. So what is the first column? Unifier. Let's leave out Unifier for a second. Unifier is there. Okay, fine. We understand the concepts of Unifier. That is fine. Leave out that. We'll talk about the physical column names. What is the first column name inside my table? ID. It is there. What is the second column name? Column A. Third, column B. Fourth, created date. So if you see the records, how are those aligned? Based on the same order, right? ID, column A, column B, created date. You can clearly see ID, column A, column B, and created date. But here, if you observe carefully, leave out Unifier, you know that Unifier, why it gets added. But now watch out this. How are the tables aligned? How are the records aligned? I mean to say column names, ID, column A, column B, created date, right? But why I'm getting created date as the second row here in this output? Next, immediately after the ID. Why not column A? Just like in this example. It should appear like in the same format. That is the rule, right? Rule, guys. So you have to when you show DB, when you just fire DBCC page, it will show you the output in the same order. It's not about the output, guys. That's about the page architecture and how the records are aligned. So when you are creating a table and you are inserting the records, it will be based on this order only. Okay, we are just seeing that output. So it is ID, column A, column B, and created date. But all of a sudden, for partition table, something got changed. What is that something that got changed? It's nothing but ID is coming up. That is the first row. Because we have created cluster index. That is the reason you are seeing first column as ID. And second column should be column A. But that is not the case. Second column is popping up as created date. So why it is happening? Why created date
Because
is
we
coming to
have
picture?
You
Yeah,
have
partition
created a
table by
partition
this.
function on the create date, right?
Okay,
Yes.
so let's drop the table just for a second. So if you can understand concepts like this, and if you just go for interviews, just imagine what happens. This is what you should do. It's all about understanding the concepts. You can practice this for yourself. There is nothing great, simple examples. Okay, I just dropped the table. And again, I'm creating same thing. Just wait for it to finish. Okay, and I'm not creating cluster index now. I'm just saying dbccind. Okay, I'm in dbccind and I'm pulling up one of the pages. I'll take the first page itself. I'm not creating index. I didn't create any cluster index. So now if you see the records, okay, it is ID1, column A, column B, created date. Created date is at the fourth record. It's like appearing like a fourth record. It's as per the order of the table. right? ID, column A, column B created date. Why? Why now I didn't get that created date as the top column or next after the ID, something like that, when I didn't create any index? Why after creating the cluster index, created date came into picture immediately next after the ID? You said created date is partition. That is the reason you are seeing ID followed by created date. That's right. I do understand it. That's how it works. But my question is, I didn't create any index, even in fact, non-cluster index also. So if you see here, immediately, I'm not seeing created date as the first record. So it is based on the alignment of the table. So it is ID, column A, column B, created date. Exactly. ID, column A, column B, created date. Even now we have partition, as you can see. So we do have partition. Let me show you that. Where is output? Here.
But is it still acting as a heap table, right?
It's a heap table. It's a heap table. Okay. Even here. So you are seeing the partition number 2. So partitions are there. But what you have to understand is when I'm creating the cluster index, okay, immediately cluster index is taking the help of the column on which you are creating the partition. Means here in my case, it is created date. So what SQL is trying to achieve here is, okay, you created cluster index on different column, not on the partition column. If you see here, my partition column is on created date and my cluster index is on ID. So if you create cluster index on different column apart from the partitioning column, so SQL Server internally first organizes the table based on cluster index, like here in my case ID, and then immediately it takes the help of partition column immediately. So I will show you. Now I will do one thing. I will create a non-cluster index on column A. You will see what happens. I think not here, here. And baby just got up. What is the time? 10:15. Okay. This is very interesting. We just created that. And we'll take DVCC IND. Even now it is heap table, guys. Even now it is heap table because we don't have any cluster index. Oh, sorry. Getting or not getting?
Yeah.
Okay. If you are saying yes, that's fine. So I will, this is how it is aligned for non-cluster index pages. So I have to take one of the page. I'll take 2100. Same number 21120. Let's see how it now. Okay, this is non-cluster index. Okay, so we created non-cluster index on column A, right? So that is the first column as part of the index definition, column A, and you can clearly see RIDs coming into picture. Okay, RIDs, because this is heap table. Clearly, you can see that. The beauty of this is created date. Did I add created date over there? Any index on created date? Nothing. Are you getting the concept, guys? This is very, very, very important. If you can understand this, game over. Did I create any index on created date here in this example? So it is create table and inserted few records, and I just created, okay, let me comment out this or let me take out this survey. And this is how it looks. I just created non-cluster index only on column A. This table is having only one non-cluster index on column A, nothing else. How come created date came into picture when I'm referring to pages of non-cluster index? Okay, so this is what happens internally, even though you are not created any indexes on your partitioning column gets added into all of your index definitions by default. I mean, index that created date. Here we're talking about created date. Created date comes and sit along with your non-cluster index and cluster index as well. Okay, I repeat this. This is the most important topic, and this is what you should understand. When you are doing a partitioning on any table, okay, any partition table, go and see your partitioning column. That partitioning column will have the values automatically into your non-cluster indexes and to cluster indexes. Okay, that is what happens with partitioning columns.
Can we see the generation script for the existing adding columns?
Means I didn't get your question. Come again.
We can generate a script and can we see the created date, every time it is added, right?
Every time it gets added. So you mean to say like generate a script.
Generated, we created the index.
Okay, you want the index definition, right?
Yes.
Okay, let's
It's
do.
C, but I'm asking.
Let's do that. Partition table is the one. Okay, this is the partition table and these are the indexes. I just created one index, nothing else, non-cluster index. Okay, let's understand the definition of this. Okay. So what it is showing, create non-cluster index name on table name, column A. I just created non-cluster index on column A. Are you seeing created date as part of your index definition? No. But still SQL Server will add that partitioning column as part of your non-clustered index definition and the table itself. Cluster index is nothing but table. That's the beauty of internally, just like Unifier. That is the reason I brought the concept of Unifier for you people to digest about Unifier first. In the similar fashion, what happens is that here, along with your Unifier will come into picture. That's a different story. Leave about Unifier for a second. This partitioning column on which you are partitioning on, that gets added automatically, just like your Unifiers. That is the hidden secret. Okay, it needs that partitioning stuff because this is all required for your partitioning elimination. Why you are doing partitioning? Because you don't want to retrieve all the records. If you are dividing based on partitions and if you are firing any query, so it has to go and do only that particular range. It's nothing but partitioning elimination. What we call it as nothing but partitioning elimination. So that is what happening. That is what it is doing internally. Okay, so again I'm saying what happens when you create a partitioning. Even though if you are not created any index on your partitioning column, here I didn't create any index on my partitioning column, but still it get added automatically. It gets added to your clustered index definition as well as your non-clustered index definition. Okay, clear or not clear?
It's clear only. SP depends that created index name. It will give any.
No, it won't give you. See, I will show you SP help index and also I will throw SP help also. SP help index table name, right?
SP depends.
SP depends. Oh, is there anything like SP depends? I don't know. Let me first fire this. As you can see, I have only one index. What is that SP depends? Is it internally for you? I don't know because I never made use of SP depends. Nothing. It's not showing anything. Okay, so this is the trickiest part, guys. If you can get this concept, then you will understand some weird errors that comes up for your partitioning when you are doing switch operation. So these are all the concepts. They are all interrelated. That is the reason I'm showing you step by step. Any questions here? If you don't understand this, the next example you cannot understand. That is the problem. So that is the reason I'm asking you, did you get the concepts or not? Okay, everyone is silent means I'm hoping that you got the concepts, or else you have not understood at all. Only two use cases.
Yes, also we understand.
Okay, fine. Then what you will do is, let's imagine, okay, let's imagine you have to carry out some partition switch. What is switch? How many of you are aware of partitioning switch? Switch we did discuss in my previous sessions. What is partitioning switch? Switch is nothing but you are pulling out the records from that particular partition and you are going to dump that contents into another table at one shot. Imagine you have to delete the records of 2017. In my case, we are having records of 2017, 2018, and 2019. Okay. So imagine I got a requirement where I have to delete the records from anything with 2017 year. Okay. Then what I have to do if it is normal table, if it is not partition table, what I have to do? I have to create a loop, or I have to delete the records in small batches, because if you do it at one shot, it will eat up your log space, and you will get some problems. But in case of partitioning, and if I ask you to delete the records of 2017, it's just a click, just in 1 second, not even a second. It's a metadata operation, so it happens in just a fraction of a second. Means partitioning switch, what it does, it removes all the records from the main table, and it will insert those records into the sub table. Means whatever the temporary table that you're going to create, you can place that into that table very instantaneously. That is the beauty of partitioning. So switch is the one that makes you to do that. Partitioning switch. You are switching what you are switching. You are switching the data based on the requirements. You will switch that partitioning from that particular thing to another table. Means delete, it's nothing but insert into table name, select star from table name. Something like that internally. Okay. So let's understand this and what errors you will get. Should I stop here, or is it okay to continue? I'm a bit confused. Hello?
Yeah, hi Chinky. I think we can stop here if others are okay. Like maybe once you upload the video, we can go through it, and
Okay,
then in next
okay.
session.
Yeah, no problem. I'll take tomorrow. So please watch this current video
Mhm.
completely, get your concepts, get those things digested, and tomorrow I'll show you why I discussed all those things and what are the errors that you're going to get when you're doing partitioning switch. Okay.
Okay.
Okay. Thanks, guys.
Same
Thanks
time,
for your time.
Vamsi.
Same time, most probably same time, because I am dependent on my baby. If he wakes up and if he cries, I can't do much. So most likely the same time.
Okay. Okay.
Okay.
Fine. Fine.
Yeah. Thank you.
Thank you.